Hello guys, welcome back to MathZone African Motives. We are still on our revisions for our mathematics grade 10. So this is a full paper revision that we are going to have on the November 2022 exam, which was written from the Gauteng province. So that is it, guys. That is our paper one revision that we are going to consider, which is 2 hours, 100 marks. So make sure that you do read your instructions and information that you are given. Make sure that you read everything properly. Also, the issue of working, show every working, and also make sure that where necessary, answers should be rounded off to 2 decimal places unless stated otherwise. Unless stated otherwise, you must leave your answers to 2 decimal places. Then make sure, like I said, read each and every part of the instructions that you are given there, the instructions that is important. So we are not going to waste much time. Let us quickly rush through our questions. On question number 1, you are given 1.1 to factorize the following expressions fully. We are supposed to factorize completely, that is to factorize fully. We're supposed to make sure that the factorization is done up to the last stage. All right. So let's consider the first part of our question, which is 1.11. We are given this as 2x to the exponent of 6 minus 8. And they say factorize. Remember the golden rule? You have to factor out what is common first. If there is something that is common, make sure that you do so. Factor out what is common. So between 2 and 8, is there anything that is common? Do we have the highest common factor between 2 and 8? So you see that 2 is the highest common factor comparing the factors. Remember, 2 is just 2. Prime factors that you consider in 8, we've got 2 into 8. 8 divided by 2, which is 4. You divide again by 2. That's a 2. 2 into 2, that's a 1. So if you consider there, we just have a 2. And also we have got a 2. So if we take this, that is the common factor, the common number that we have. We have taken these 2. We are not going to take these 2. Remember the condition of your HCF. You're supposed to take what is common between the 2. So 2 is the one that is common. So if we factor out the 2, what is going to happen here? What are we going to remain with? We divide this, 2x to the exponent of 6. If we divide it by 2, it's going to give us x to the exponent of 6. The same part of this minus 8. If you divide 8 by 2, what are you going to get? That is going to give us a 4. It is very true that we have factorized. We have factored out this number, which is 2. But is it fully factorized? No, this one is not fully factorized. Why? If we check properly, we are going to see that what is remaining inside of this bracket is a difference of 2 squares. Why am I saying so? Remember that a difference of 2 squares is when we have perfect squares. A to the exponent of 2 minus b to the exponent of 2 is equal to a minus b into a plus b. As long we can write these numbers raised to the power of 2. A to the power of 2, b to the power of 2. So we cannot see that this is to the power of 6, this is to the power of 1. But I'm saying it's a difference of 2 squares. Why? If we take a closer look, this x to the exponent of 6 can be written as x raised to the exponent of 3. Remember, this is 6. We need 2. Remember, we need 2. So if we divide 6 divided by 2, it's what? That's a 3. So meaning to say it is the same as x raised to the exponent of 3 and raised to the exponent of 2. Remember, what we actually want to see is this exponent of 2. Minus 4. How can we write 4 as a number raised to the power of 2? That is simply the square root of 4. What is the square root of 4? Remember, that's a 2. So that's 2 raised to the exponent of a 2 again. So this is what exactly we want to see. This part is the same as this part. Expand this, multiply this. 3 times 2 is what? That's a 6. 2 to the exponent of 2 is what? That's a 4. We haven't changed anything. What we just need is to rewrite in this format so that we can properly see what is representing our A and what is representing our B. So if it is true, we are going to notice that we are going to have two brackets of A minus B and A plus B. So this is our A and this is our B. All right, let me indicate this one. This is our A, the whole of this part that we are seeing here. That is your A, and this is your B. So if it is truly that we've got A and B, so we are supposed to have A minus B. So A is what? X to the exponent of 3 minus B. Our B is 2. A plus B again, X to the exponent of 3 plus a 2. A plus. This is our A. This is our B. So that is just like that. You factorized. So if you properly understand this, you can simply have your difference of two squares in those brackets like that. Or you can simply ask yourself, what is the square root of this? These brackets that we have, they represent the square roots of these numbers. So you can easily ask yourself, what is the square root of x to the exponent of 6? Remember, the square root of x to the x, if you're given an exponent, you simply divide the exponent by 2. Inside the square root, there's a number there which is 2, but we do not write it, but we must know that there's a 2, which is invisible. So if we divide by 2, what are we going to have? X to the exponent of 3, which is this one. You write this also. Remember, one bracket is going to subtract, another one adds, or one adds, another one subtract. You move on to another number. Square root of what? Of 4. What is the square root of 4? The square root of 4 is 2. Remember, plus or minus 2. So one is going to be having the 2, another one minus 2, like that. So you can simply ask yourself, what are the square root of these numbers, instead of writing in the form of a squared minus b squared. This is the way that you understand. All right. Let's move on to another question. Again, it is to factorize, and there we've got 4 marks on 1.12. We are supposed to factorize minus x plus x minus y to the exponent of 3 plus y, like this. So if we take a closer look of our question, we might see as if there's nothing that is common, because this is x on its own, this is y on its own. But here we've got an expression. X minus y is an expression being raised to the exponent of 3. So let's ask ourselves, can we have another exposed? They gave us this bracket, guys. You have to consider the complicated part. The complicated part is on this bracket. Can we expand this to the exponent of 3, to the power of 3? It means we have to expand. It's a lot. So instead of expanding that, check and see if we can rewrite what is remaining, these two, the minus x and the plus y, these two. Can they be written also in this manner of x minus y? So we're going to start with that one. It's a plus here, guys. So it means there is no effect at all. I'm just going to write it as it is x minus y to the exponent of 3. So I want to rewrite these two in this form of x minus y. But if you check here, this is a minus x and this is a plus y. They are not the same. Here it's a plus, but here it's a minus. Here it's a minus, but here it's a plus. As we can see, they are different. So how can we make these two to be different? What can we do? We are going to factor out a negative. The moment you factor out a negative, this is it, guys, minus x plus y, like this. The moment you factor out a negative, let's say -1, like this, so that we understand each other, this becomes a positive because it will be minus x divided to -1, minus x over -1. That will be a positive x. This will be a plus y, like this, divided by -1. So plus and minus gives us what? A minus. So it will be -1. So as we can see, just to make these two to be the same, factor out a negative, then they are the same. If you understand that one. So that is the idea there. So meaning to say we've got x minus y raised to the exponent of 3. We have factored out minus 1, and we are remaining with a bracket of x minus y. By doing so, we are not having common terms, but we are having common expressions. Remember, this is an expression, x minus y, which is also common to this one, x minus y. What is the exponent of this x minus y? It simply means to the exponent of 1. If the exponent is not given, if the power is not given. So how can I factorize now this? If we consider properly our golden rule, there is something that is common. This bracket is common. Even though it's an expression, but it's common. We can see it here. We can also see it there. So we can factor it out. So if there is an exponent and also there's an exponent like this, you are taking out the highest common factor. You take the one with the smallest exponent, x minus y, the one that has got the smallest exponent. So it's to the exponent of 1, guys. That means there's nothing that I have done. You can just leave it like that. So the moment I factor out this, what is going to remain here? Because we have factored out. All right? Remember, we have factored out this x minus y and this x. What are we going to remain with? It will be like this, x minus y to the exponent of 3 over x minus y like this. So remember, this is to the exponent of 1. And you are dividing the same basis. What are you going to simply do? You subtract the exponents, x minus y, 3 minus 1, which is what? Which is 2. So we are going to remain in this bracket with x minus y being raised to the exponent of 2. Minus, you factored x minus y and x minus y. So what is going to happen? They're simply going to divide x minus y over x minus. They're the same. They'll just cancel and remain with what? With a 1. So this is what you're going to have at the end. It's true. We have factored out what is common, but is it completely done? Is it fully factorized? No. Why? If we check properly, we are going to notice that just like what we had before, we have a difference of 2 squares. So we are going to have x minus y like this. Then the 2 brackets of our difference of 2 squares. Remember the concept of your difference of 2 squares. The square root of this x minus y. What is the square root of this x minus y squared? The square root of x minus y squared is simply removing the square that is there. You remain with what? With x minus y. Remember, 1 is a perfect square. What is the square root of 1? The square root of 1, remember, plus or minus 1. So we've got 1 is going to be a negative. The other bracket is going to add the x minus y that we got here. Then we add a 1 this time. Just like that. So this is now fully factorized. We have also to consider the difference of 2 squares at the end. So even just like the previous case, which I used the a squared minus b squared, which is equal to a minus b into a plus b, you can also do that because you can say that it's already raised to the exponent of 2. X minus y to the power of 2 minus 1. 1 is same. It can be, remember the square root of 1 plus or minus 1, the cube root of 1 is 1. So 1 can be raised to any power and it remains as a 1. So we can raise 1 to the power of 2 just for us to have the difference of 2 squares concept, the square and the square. So this is your a and this is your b. So as you cannot, we're going to have a minus b, a plus b, just like what we had before. So guys, this is how our questions are simply taken as. They just want you to refer back your revisions, understanding of the difference of 2 squares. As we can see, it is very, very important in your revisions. All right, checking another question, which is 1.2. We are given to simplify the following completely up to the last stage. Simplify until last stage. First question, it is given 1.21 x to the exponent of 1 over 2 minus 3 raised to the exponent of 2. What does it mean? This is simply expanding of brackets raised to the power of 2. Remember from our basic expansion of brackets, I said if you're given, let's say we've got a minus b raised to the power of 2. We are going to have, this is the first term, this is the last term. So we are going to have the first term squared minus 2 times the first term times the last term plus the last squared. So what is important? Which one is your A? Which one is your B? Understanding this, guys, with this one, you can simply expand this. So what is representing our A in this case is the first term, x to the exponent of a half. The part of B is the 3, this one, the 3, not the minus. The minus, leave it. The sign is leave it on its own. If there was a plus here, this was simply going to be a plus. So do not mind the sign. Mind this, the first squared. What is your first? This is your A, this is your B. So our first x to the exponent of a half squared. Minus 2 times the first times the last. So that is minus 2 times the first. What is our first? X to the exponent of a half times the last term, which is 3, plus b squared, which is the last term squared, the last, which is b. So that is 3 squared. So this was going to give us the answer, guys. We can simplify this. So x raised to the exponent of a half and raised to the exponent. Remember your laws of exponents. That will be a half times a 2. This exponent multiplies. So what is half of 2? This is the same as 2 over 1, guys. Half of 2 on your calculator, 1 over 2 times 2. That's a 1. Half of 2, that is 1. Not 4, but 1. So it's x to the exponent of 1. But we do understand x to the exponent of 1 is same as what? It is the same as x. You move on to the next stage. Just multiply the numbers here. Minus 2 times 3. That is minus 6x to the exponent of a half. Plus 3 raised to the exponent of 2. 3 to the power of 2. That is what? That is 9. You're done. You have expanded this, simplified, using your basic rules of algebra as you consider your algebraic expressions. We could have expanded because we know that to the exponent of 2 means that there are 2 brackets there. We can also do that. Write your 2 brackets, x to the exponent of minus x to the exponent of half minus 3 like this. Another bracket, x to the exponent of half minus 3. There are 2 squared. It's a repetition, 2 brackets as they are. You repeat them. Then you can use the FOIL method. Let's consider the first term. So this term is going to expand everything in the other bracket, meaning to say x to the exponent of half is going to multiply x to the exponent of a half, x to the exponent of a half times x to the exponent of a half. What are you going to have? Remember, if you're multiplying, the bases are the same. You add the exponents from your laws of exponents. So that will be x to the exponent of a half plus a half. And what is half plus half? That is a 1. That is same as 2 over 2, which will give us a 1. So meaning to say we are going to have x. X to the power of 1 is same as what? X. Still on the same x to the exponent of half, we multiply this to minus 3, the last part that we have there. So it's minus 3 times x to the exponent of half, which is minus 3, x to the exponent of a half. That is what you're going to have. Considering the outer part, because we're done with this first. Let's consider this outer part that we have the minus 3. It has to affect the same way, this minus 3. So it must affect the first term here, minus 3 and x to the exponent of half. So it's going to be minus 3 x to the exponent of a half. It multiplies what is on the outer part there, the last term there, supposed to be minus 3 and minus 3. So minus 3 times minus 3 is what? That's a positive 9. So with this, we can collect the like terms. Which like terms? the part where we have x to the exponent of a half. These are like terms, same x and same power, the same variable and the same power. That means these are like terms. So we're going to have x minus 3 minus 3, that is minus 6, x to the exponent of a half plus what? Plus 9, just like that. So as you can see, still with your FOIL method, you can win. You can have the same answer, just like what we had in the previous case. Simplify on 1.22. That's another question that we're being asked to simplify. What is it that they want us to simplify here? Where we are given x to the exponent of minus 3 divided to x to the exponent of minus 5 plus x to the exponent of minus 2 raised to the exponent of minus 1. If we are to consider this, we are going to notice that here there's a division, so we can also simplify using the laws of our exponents because there is a division there. Remember, under your division, x to the exponent of a, when divided to x to the exponent of b, the bases are the same. We are going to subtract the exponents. So meaning to say I can do that because I can see that the first part here, these exponents are the same and we are dividing them. There's a division. So under the same base of x, minus 3, we subtract a minus b. We subtract this exponent. So it is going to be minus 5 like this. We subtract minus 5. But on this case, there is addition. We never had a law where addition was being used. No, we never had a law like that. So on the addition, just leave it like that. But we can simplify here now. We cannot add. We cannot use a law of addition. There's no law. But on this case that is remaining, guys, we can apply the law there. If there's an exponent, there's also an exponent. Remember, x to the exponent of a to the exponent of b will give us x to the exponent of ab. You simply have to multiply these exponents, negative 2 times negative 1. That is going to be x to the exponent of a 2. All right. Using our calculators, we can simplify minus 3 minus 5. This is simply a plus there. So it's minus 3 plus 5, which is 2. So that's x to the exponent of 2 plus, we are still adding. This one, there's no law that we can use. That's x to the exponent of 2. But we can see that these are like terms now because same variable, same exponent, same variable, same exponent. So what is the coefficient? If the number is not written, that's a 1. So you simply add now the coefficients 1 plus 1. That is going to give us what? 2. So that's 2x to the exponent of 2. So this one is just same like you're given y plus y. That is equal to what? To 2y. There's a 1 here, there's a 1 here. So you add 1 plus 1, which is 2y. So that is how we can actually have our question. So there are so many ways we could have used other laws on this case to say, okay, there is a negative that we are given there. So from our laws of exponents, how do we rewrite a negative exponent? X to the exponent of minus n is given as 1 over x exponent of n. So this is the same as 1 over x to the exponent of 3 divided to 1 over x to the exponent of 5. Plus, you simplify this just like what we simplified, minus 2 times minus 1, which gave us a positive 2. You are now at this stage. You are not using the laws there. We are just working with the basic of your simplification, where there's a division. How do you simplify a division? You introduce multiplication sign. So it'll be 1 over x to the exponent of 3 times. The moment you introduce a multiplication, you invert the second fraction. You interchange these terms. X to the exponent of 5 will be written on top. So that's x to the exponent of 5 over 1. Adding to x to the exponent of 2. This is where you are. There you are multiplying, which is very true. So we can simply consider the numerator to the numerator. Or we can even ask ourselves to say, here, we can reduce these terms as long as it is between the numerator and the denominator. Remember, like 1 over 2 times 8 over 1. You can even reduce 2 into 2, that is 1, into 8, that is a 4. You can do that. Here, there are 3 x's that we have. Here, there are 5. So if we cancel these 3 x's into these ones, which are 5, how many will remain? We are going to remain with 2 x's there. So meaning to say this is x to the exponent of 2 multiplied to 1, which is simply x to the exponent of 2. Remember, guys, if you're given x to the exponent of 2 over 1, just like 2 over 1, it remains as a 2. So this one, it remains as x squared plus what? Plus x squared, this one, that is remaining here. So this is the simplification that you're going to have. As you can see, just like the previous case, we are at this stage, this is the same as 1, this is 1. So you can simply add these two terms, that it will be 2x to the exponent of a 2. So as we can see, it is simply one and the same. You can actually obtain the same answer. I don't know which way are you using there to simplify, but you can have that in any way that you understand. On 1.23, it is also to simplify, and this is part of our exponents that we need to actually apply in this case. We are given 5 to the exponent of x plus 1 multiplied to 4 to the exponent of x raised to the exponent of 3, everything over 2 to the exponent of 5x minus 2 times 10 raised to the exponent of x minus 1. So I need us to consider this question properly. If you're given this type of equation, try by all means to rewrite your numbers in simplest form. And if I'm representing the simplest form in terms of the numbers in our simplification, it is best that you deal or you work with the prime numbers. It is best that you deal or you work with the prime numbers, the prime factors, the prime numbers. So 5 is a prime number, 2 is a prime number. But what about 4? What about 10? Can they be written in terms of the prime numbers? You can see that the 5 here is fine, and this 2 is okay, but this 4 and this 10. So which numbers are we going to use in place of this 4, in place of this 10? If, let's say, you are being given to express a number as a product of its prime factors, how would you express it? 4, LCM, we can divide by 2. That's a prime number. 4 divided by 2, that's a 2. You divide by 2, you get a 1. So you can see that 4 is from this 2 times 2. The product of 2 and 2 gives us a 4. And 2 times 2 is same as what? 2 raised to the exponent of 2. We can rewrite in that way, in terms of a prime number in simplest form. So that's 5 to the exponent of x plus 1 times the 4 is same as 2 to the exponent of 2. But there is already an exponent of x which was there. So how do you write it? 2 to the exponent of 2. There is already an exponent of x which was there on that 4. So remember, exponent multiplies 2 times 2. That will be 2x raised to the exponent of 3. This one that is outside there. You could have multiplied them, all of them. You multiply even by 3 here. Still one and the same, but you can even leave it like this. Everything over what? The 2 is in the simplest form, remember? So just leave it like that. 2 to the exponent of 5x minus 2. It is already in simplest form. Then we move on to the 10. Remember, 10 is not in simplest form. As a product of its prime factors, the smallest prime number that we can use is 2. 10 divided by 2, that's a 5. We can now use a 5. 5 divided by 5, that's a 1. So meaning to say 10 is a product of 2 times 5. So where we see the 10, it is the same as 2 times 5, like this, being raised to the exponent of x minus 1. 2 times 5, this one. It is the same. So if we consider that, we can see that there's the 5, there's a 5, there's a 2, a 2, a 2. Can we try to separate so that we can use our laws? Because where there's a multiplication, we know the laws, guys. We simply add our exponents. If it is a division, we subtract. So let's try to separate. So how are we going to separate this? This is 5 to the exponent of x plus 1 times, remember, guys, exponent and exponent, you multiply. So 2x times 3 is going to give us 6x. So that's 2 to the exponent of 6x, 2 times 3. everything over what? The 5 remains as it is, 2 to the exponent. This 2 remains as it is, 5x minus 2. There are two terms, two numbers that are inside raised to one exponent, just like AB raised to the exponent of n. It is same as A to the exponent of n times B to the exponent of n. Each term inside is affected by the exponent that we see outside. So 2 is affected by this exponent. It will be 2 to the exponent of x minus 1. 5 is also affected by the same exponent. So it is going to be 5 to the exponent of x minus 1, just like that. So at this stage, I will advise you to just work with the bases that are the same, because we consider, is it a multiplication or is it a division? Working with the base of 5, we can see that there is a 5 here. There's also a 5. That is a division, because we are saying this term divided to this one. There's a division. So remember your division, you're supposed to subtract your exponents. If you are dividing a minus b, you're supposed to subtract. So that is going to be 5 to the exponent of x plus 1. We subtract this exponent of x minus 1. That is the idea there. We have to subtract a minus b under the same exponent, under the same base, this one. But you're subtracting the powers. The same thing on the base of 2. There's a 2 there that we have that is being raised to the exponent of 6x. But we can see that there's also another 2 that we are having here. There's this 2 that we are also having, and another 2 there. So considering that we are subtracting, we are going to subtract 5x minus 2. We subtract that one, the 5x minus 2. We are supposed to subtract also that one, minus again the x minus 1. That is the idea, because they are to be divided to this. Divided is divided. Or you could have combined these two first. It's up to you. That one is up to you. So at this stage, this is where we are. Let's try to simplify further. Still in the base of 5. There is a minus there. So what are we going to have at the end? This is same as we are going to have x plus 1 minus distribute here. That's minus x. Distribute here. That's plus 1. So x minus x, that's a 0 there. You remain with 1 plus 1. And 1 plus 1 is 2. So we're going to have 5 to the exponent of 2 times. The part of 2, we do the same thing. This is the same as we've got 6x minus distribute inside. That's minus 5x minus and minus. That's a plus 2. The same thing with this minus, distribute in this bracket everything. So it's minus times x, which is minus x, minus times minus 1. That's a plus 1. So you're going to get 6x minus 5x, which is 1x. 1x minus x, that's a 0 there. So the x was going to cancel. 6 minus 5 minus 1, that's a 0 there. So you remain with 2 plus 1. And 2 plus 1, that's a 3. So it's 2 to the exponent of 3. 2 plus 1, which is a 3. So this is what we're going to have. And from there, guys, you can simplify. You can just multiply on your calculator, or you can simplify this aside. 5 raised to the exponent of 2, that is 25. 2 to the exponent of 3, that is 8. If you multiply this, you're going to obtain 200, or you can just use your calculator at that stage to multiply that. That is going to give you a 200. Just like that. So questions can be like this, where you need to apply your laws of exponents. The laws of exponents are to be taken into consideration. If we consider another question, which is on 1.24, it is again to simplify. All right, 1.24. There we are given 11, that is minus 11, everything over 2x squared minus 5x minus 12. Then definitely this we have to factorize. And how to factorize, guys, is in your hands. How are you going to factorize this? 2x squared minus 5x minus 12. How are you going to factorize this in your hands? But you can just use the basic way that maybe all of us can understand. If you do not have a 1, like when you have got a 2, this number, you can simply multiply the first term and the last term. 2 times minus 12. You multiply these two terms. You multiply them. So you're going to get minus 24x squared. 2 times minus 12, minus 24x squared. There's x squared there. Then you ask yourself, what are the products, two products or two factors of minus 24x squared? The product, the two terms that you multiply, you get minus 24x squared. But these two products that you are talking about, they must add up to the middle term that you are given. They must add up to this. We need two numbers that when we multiply the two numbers, we get minus 24x squared. But add those numbers, you must get minus 5x. So you can just ignore the x, just use the numbers that you are capable of. As you can see, guys, 24 and 5, this is best from 8 and 3. But 1 has to be a negative there so that we get a negative 24. So we're just going to put our x and our x here. So which one is going to be a negative? All right. Let's start with this one. Put a negative. Then let's consider 8x and we put a minus on 3x. If we multiply these, guys, if you multiply, you're going to get minus 24x squared. If you multiply this, you're going to get minus 24x squared. But now, when you add, the question is when you add these two, when you add, are you going to obtain minus 5x if you add? So this one of 8 and minus 3, if you add 8 plus minus 3, that's a positive 5. It will be 8 minus 3, which is positive 5, not minus 5. So this is not going to work. Minus 8 and 3, if we add minus 8 plus 3, we are going to obtain minus 5. So this is exactly what we want, where we have minus 8 and a minus 3. These are the factors that when you multiply, you get minus 24. When you add, you get minus 5x. So we are going to take those terms, replace them into the middle term. Here, in place of that minus 5x, you replace these terms as they are. Minus 8x plus 3x. Remember, this one is a positive, so it's a plus. The last term, write it as it is. So as you can see, guys, there are 4 terms. 1, 2, 3, 4. We understand that when there are 4 terms like this, we can factorize this by grouping of terms into 2 like this. We factor out what is common here. We also factor out what is common on the last 2. So on the first 2, we can see that 2x there is the highest common factor between 2 and 8. We talked about these two numbers before, but there is x squared and x. So we take the one with the smallest power, which is x. So let's divide 2x to the exponent of 2 divided by 2x. What are you going to have? That's x. 2x squared over 2x. This one and this one cancels. Here it's 1. These ones, they are 2. So if you cancel 1 in these ones, which are 2, we are going to remain with 1x. Minus 8x. This is 8x over 2x. X and x cancels. 2 into 8. That's a 4. So it is going to be a minus 4. What is common on what is remaining in these two? What is remaining there? That's a plus 3, which is remaining. So you can factor out 3 so that we have the same brackets. 3x divided by 3. What are you going to have? 3x over 3. This one cancels. You remain with x. Minus 12 divided by 3. Again, it is going to give us a minus 4. So you divide by what you factored out. You divide. This one divided by 3. This one divided by 3. Just like that. By side, by just looking into the question, you can see answers are going to be like this. So there is a common bracket, the bracket of x minus 4 and this bracket of x minus 4. It's a common bracket. So we can simply factor this bracket out. Remember our golden rule. Whenever there's something common, whether it's a bracket, whether it's a number, whether there are terms, factor that one out. So we can factor out the x minus 4. So if we take out the x minus 4, we are going to remain with what? We have removed this here. It is no longer there, this one. You have taken it out. What are you going to remain with? You remain with what? With 2x. That's to factorize. You factorize this, you remove this here. What are you going to remain with? You remain with a plus 3. So this one is going to be a plus 3. It's another bracket that we have formulated. So in this case, is there anything common between these two brackets that we can factor out? No, there is nothing common. So this is how our brackets were going to be like in our factorization, of which you can use so many ways, guys, of factorizing. All right. So that's x minus 4, 2x plus 3. All right. So we're going to have x minus 4 and another one, it will be 2x plus 3. So we have factorized this. And the other part, it is having minus 1 over 4 minus x. This is what we're supposed to have after factorizing. And we are supposed to subtract. But we cannot do that because this bracket of x minus 4 and this bracket of 4 minus x, they can be written in the same way. One can be written in another way to be the same as another one. They are different, as we can see. They are not the same. This one, they are different. This is plus x. This is minus x. This is minus 4. This is plus 4. In every situation like this, guys, like what we saw before, remember how we factored out this minus x when it was minus x plus y. You just factored out a negative and it gave us x minus y. So it is the same thing that we are having there. So leave the first term. This one is already in actual sense, like we are starting with x. Leave it like that. X minus 4 into 2x plus 3 like that. Minus 1 of this one now. You factor out a negative so that it becomes the same as what? As x minus. The moment you factor out a negative like this, it will be like this, 4 minus x. You factor out a negative, it will be minus 4 plus x. Minus 4 plus x, guys, is the same as x minus 4. We haven't changed anything. X is still a positive. Minus 4, it is still minus 4 there. We haven't changed anything. So that is what we want. It will be x minus 4. We have factored out the negative. This one is there. This one. The negative is this one. It's already there. The negative, the bracket is this one. Is the same bracket, but having that negative there. So it will be x minus 4. You factor negative so that these two will be the same. So what is going to happen with this negative? It is affecting this sign. Negative, negative, it will be a positive. So that's minus 11 over x minus 4 into 2x plus 3. Negative, negative, that's a positive. 1 over x minus 4. So you see the purpose of making these brackets to be the same. It is because when you are to add now, we are not going to have many brackets. We are just going to use one bracket of x minus 4 because it is common. This bracket here, x minus 4, is the same as this x minus 4. So on your division, you are not going to have two brackets. You write it once, x minus 4. Remember your LCM or your LCD. And the 2x plus 3, it is also to be taken. So if you had this one, x minus 4, 2x plus 3, and that one for the one that we had, which was having 4 minus x, it means we're going to have another bracket here of 4 minus x. No, no, no. We cannot have that. Because these two can be the same. They can be written in the same manner. So if that is available to happen, please do so. Now we can divide our LCD into this. So as we can see, guys, the bracket of x minus 4 and this one of x minus 4 will cancel. The bracket of 2x plus 3 and this bracket of 2x plus 3 will cancel. So you remain with what? With a 1. So you assume as if you are canceling. You don't cancel. You just assume as if you are canceling this into this. So that's a 1 times minus 11 plus divide this into this. As you can see, the x minus 4 and the x minus 4 will cancel. And you remain with what? With 2x plus 3. Like I said, you assume as if you don't cancel, but just assume as if you're canceling. What was going to remain? you're going to remain with the 2x plus 3. So that's a 1 multiplied to 2x plus 3 that you are remaining with. So you divide to this, whatever that you get, multiply to the numerator. Same thing, your LCD, this one, you divide to this, whatever that you get, multiply to the numerator. So we can simplify further from there. 1 times minus 11, that's minus 11. Distribute this by 1 into everything. That's 1 times 2x, which is 2x, 1 times 3, which is a 3. Everything over the same brackets as they are. We're not going to change this. We're just going to rewrite as they are. Let's simplify further. We've got like terms to be considered there. So just going to write our 2x. Then consider the like terms, minus 11 and a plus 3. These are like terms. So on your calculator, you can even simplify that. Minus 8 plus 3. That is going to be a minus 11 plus 3, which is going to give us a minus 8. Everything over what? X minus 4 into 2x plus 3. At this stage, many of you are tempted. You think that this is the last stage of simplification. No. Try by all means to check your numerator, because this simplification that we are doing, they mentioned that it must be done completely up to the last stage. It is supposed to be done up to the last stage. So most of times you are tempted to leave your answer like this. No. Check again. The numerator is it in simplest form. If you check properly, you're going to see that it can be factorized. 2x minus 8. I think we guys have been doing this 2x minus 8 factorization. I think we also saw it. The toolkit with this one was 2x squared minus 8x. But you can see it's the similar part. You can even factorize that. 2 is common. There 2 is common. You can simply factor out 2. What do you remain with? 2x divided by 2. That's x. Minus 8 divided by 2. That's a minus 4. Everything over what? The same brackets as they are in the denominator. 2x plus 3 like that. So this is it. The numerator and the denominator, they are the same. The x minus 4 and the x minus 4. These can cancel each other. That's why we've got a 1 there. So it's simply 2 times 1, which is 2 over, here there's a 1. 1 times 2x minus 3. 2x plus 3, that's 2x plus 3. So you can just leave it like that. You can put the brackets. It's up to you, or you can just leave it like that, because we do not have any other bracket to be considered. So we can just leave our answer without a bracket. So that is how questions can be like if you check properly. These are the stages that you need. Make sure the factorization first, that quadratic expression. This factorization also is in your hands. How you factorize, maybe there's another method that you have been taught on how to factorize. There are so many ways there. It is up to you. You just have to choose which one is best. But the stages after factorization are the ones the same way that you need to apply that simplification. And up to the last stage, make sure that simplification is done completely. 1.2, they are saying, determine the value of D if 3x plus 2 is a factor of this. If we refer to a factor, there's this part actually that you need, even in your grade 11, you also need to know that. Let's say we are given that it's a factor like this. If 3x plus 2 is a factor, Okay, just solve this for x. Just solve for x, all right? These are the stages that you just need. Solve for x, okay, by equating it to 0. By equating it to 0. Just solve for x by equating it to this expression. You take it and equate it to 0. 3x plus 2 is equal to 0. You solve. You are solving, guys. This is your grade 9 mathematics. Take your negative 2 to be a negative on that other side. Divide by 3. Divide by 3. So x is equal to what? Minus 2 over 3. You have solved for x. So what does it mean? It means if truly this is a factor like what we are saying here, f of x is supposed to be equal to 0, which means f of this number. So f of minus 2 over 3 is supposed to be equal to 0. What does it mean when I say f of minus 2 over 3 is supposed to be equal to 0? It means wherever there is x in this equation, in this expression, this one, wherever there is x, we can put minus 2 in place of x. Where there is x here, we can put minus 2. So it will be like this: 6 times minus 2 over 3. Where there is x here, minus 2 over 3 squared, plus, in place of x, this one. So it's d times, so this one is like d times minus 2 over 3. Minus a 10, this is supposed to give us a 0. So as we can see, it's an equation that we can solve for what? That we can solve for d. Remember, the question is we need the value of d. So we have an equation that we can use to solve for d. There are so many ways that we can use, guys, to find this value of d. I don't know the way that you have been taught. Just maintain that. Revise as much as you can. All right. So if I'm to simplify, here I can see this one on my calculator. I just have to take this, combine with the minus 10, guys. Use your calculator there to simplify that at once with the minus 10. It is going to give us a single value in that case. We are going to have a single value. Sorry for that there. So I needed to share this part here. So this one, it is going to give us a single value, which is 6 into minus 2 over 3 like this, raised to the exponent of 2 minus 10 like this. So that will be minus 22 over 3. So we have got minus 22 over 3 there. Minus 22 over 3. Then d times minus 2 over 3. That's minus 2 over 3 d, which is equal to 0. So remember, you need to solve for d. So take the minus 22 over 3 that side. It will be minus 2 over 3d is equal to 22 over 3 like that. It's a positive. So you can even divide by this negative 2 over 3 here, divide by negative 2 over 3. That will cancel. So there we have got the value of d. So d is equal to what? The answer that you are having here, let's just put this as a positive, 22 over 3 like this. We divide this one to minus 2 over 3 like that. The calculators are there, guys, for assistance. So that will give us a negative 11. So like I said, there are so many ways of simplifying this. There are so many ways of simplifying this, solving for this. You just have to choose like which one is best in your simplification, as you have had these questions before in your revisions at school, this and that. You just have to consider also the way that you have been taught can be an easier way. There are so many ways. We just need time, guys, to refer to these, guys. There are so many ways that you can use in this mathematics, guys. There's a lot that you need. So we just need time so that we can dwell much into these revisions. On question number 2.11, it was solve for x. Whenever you're given solve for, it is to find the value of x. What is the value of x? What is the value of x? So the brackets are there and being equated to 0, 2 brackets. Remember, the product is the 0 product. The concept, the 0, 1 bracket must be equal to 0. So it's either 3x minus 1 is equal to 0, or it's either this bracket of x plus 2 is equal to a 0. So we can solve for x, guys. From the first one, it's now a linear equation. Take minus 1 to the other side. It becomes a plus 1. Simply divide by 3. Both sides, that's a product there. So x is equal to 1 over 3. Or we can do this. Transpose the 2 to the other side. It becomes a negative. So x is equal to minus 2. So just like that. So these are the possible values of x. X can be this. or x can be this, minus 2. That was a direct question. On 2.12 also, we are supposed to solve for x as we are given there. That's 2.12. 3 to the exponent of x minus 2 times 3 to the exponent of x minus 1 is equal to 3, and you're asked to solve for x. So the luck part is that we can see that this is in terms of x. This is already in terms of x. In terms of this 3, there's 3 to the exponent, 3 to the exponent of. Our laws of exponents tells us that if we are subtracting like this, an exponent with a negative, like we have x to the exponent of a minus b, a minus like this, it means these two were dividing. X to the exponent of a was divided to x to the exponent of b. So if I have 3 to the exponent of x minus 1, I can do the same thing to say this is same as 3 to the exponent of x over 3 to the exponent of 1. That's how we ended up subtracting x minus 1, because we're dividing the same basis. So we can rewrite this in the same manner. This is same as 3 to the exponent of x minus 2 times 3 to the exponent of x over what? Over a 3. 3 to the exponent of 1 is same as what? Same as 3. This is equal to 3. This is equal to 3. So if you consider properly, you can say, okay, there's a fraction. Let me remove the fraction, which is fine. You can do that, or to clear the fraction, or you can even work with this number as it is. Because these bases are the same, guys. We can just consider this, and there is no need of us even this one. It's the same. These are like terms. So we can simply subtract here, guys. These are the same. This is a 1 here, and this is what? Minus 2 over 3. We subtract that 1 minus 2 over 3, it's what? That is 1 over 3. 1 minus 2 over 3. So we're going to obtain 1 over 3. So it's 1 over 3 times 3 to the exponent of x. Remember, we are subtracting. So this remains as it is, your like terms. It is equal to what? To 3. 1 over 3. We can divide by this 1 over 3, both sides, or you can simply multiply by 3 to remove that 1 over 3, multiply by 3 like this. So we are going to have 3 remaining raised to the exponent of x is equal to 3 times 3, which is 9, or 3 to the exponent of 2. We are multiplying the bases which are the same, just add the exponents. We know that if the bases are the same in the base of 3, they're the same. Whether it's base of 2, it's base of whatever base, the exponents will be equal. So therefore, x is equal to what? To 2 from there. X is equal to 2. Or like I said, at this stage, another way from this stage, you could have simplified it here. If you do not want to apply this at this stage here, the way you see this 3, this is 3, this is same as 1, this is same as 1. So you can remove this fraction by multiplying each and every term by that LCD. What is the LCD of 1, 3, and 1? That is 3. LCM. So we multiply this by 3. We multiply this by 3. Each and every term we multiply by 3. So 1 into 3, that's 3 times this, which is 3 times 3 to the exponent of x. Minus the 3 and the 3 cancels. You remain with what? With a 2 there. So it will be 2 times 3 to the exponent of x, which is equal to 3 times 3. What is 3 times 3? That's a 9. Or 3 to the exponent of 2. We can just multiply 3 times 3, 9. These bases are the same, which is fine, but it's a subtraction. So we cannot use the laws of exponents, but we can just use our normal algebraic simplification to say these are referred to as like terms. This is the same. So we can subtract these numbers as usual. 3 minus 2. What is 3 minus 2? That's a 1. So 1 times 3 to the exponent of x is same as what? It is same as 3 to the exponent of x, which is equal to what? To 9. The bases should be the same so that we can solve for x. 3 to the exponent of x, 9 in the base of 3 is same as what? 3 to the exponent of 2. So therefore, x is equal to 2. just like that. Just like that. So as you can see, the simplification thereafter, it was in your hands. The way that you're going to simplify, you can use that idea of just working with the fractions as they are. If you want to avoid the fractions, it's also in your hands. You can avoid that. On question 2.2, we were given a simultaneous inequality where we are given two inequalities, or we are given compound inequalities. -1, so we're asked to solve for x in this inequality on 2.11. So that's -1 less than this 1 minus 2x over 3 less than 3, like that. You're asked to solve this simultaneously. That's at the same time. That's a compound inequality there. So in our solving, guys, we are used to this. We can just solve as usual, but we are solving at the same time. So there is a 1. We can take the 1, this one, to the other side. It becomes a minus. The same thing that we are doing on this side is supposed to be done on the other side. So as we transpose this one, you remember we are dealing with the middle term, this one, this middle term. That's the part that we are working with from this middle term. But we can start with the 1, this one. So what is be the effect there? -1. The moment we take it, it becomes a minus. So it's -1, which is what? -2. Less or equal to, we have removed this, remember? So we are remaining with what? -2x over 3. So you're going to remain with -2x over 3 is less than. Remember, also taking 1 to this other side. Same way that 3 minus 1, it was a plus. The moment it jumps that inequality side, it changes the sign. So 3 minus 1 is what? That's a 2. This is where you are. Other one, you transpose that one. It affected because it was a minus. Then it became, okay, let's check this one. The number, this is 5 now. I'm surprised about this number, guys. This is a 5 here. So that's 5 minus 1, which will be a 4. So let's correct this. That will be a 4 there. We have a fraction. When you want to get rid of the fraction, it's up to you. You can divide by the -2 over 3, this one, because it's multiplying that one. So again, guys, this is your understanding. Whatever that you're doing must be done on the other side. So you can simply, because you want to remove this -2 over 3, it is a product that way. So you can divide by -2 over 3 here. You can divide by -2 over 3 here. But noting that the moment you divide by a negative, the sign changes. So you're going to divide, you're going to get your -6, but the sign reverses, it changes. It will be like this. It is reversed. By dividing by a negative, or when you multiply by a negative, the inequality sign reverses. Remember, you are dividing by 2 over 3 so that you get rid of, by -2 over 3 so that you get rid of this. What is remaining after that? What is remaining is just x. The same thing, 4 divided by -2 over 3, the inequality sign reverses. The moment you divide by this, the inequality sign there reverses. Okay, this is negative, so that will be positive. Yeah, sorry for this, guys. And this one, 4, and this will be a -8 there. Let's just correct that, guys. Here, the inequality sign is reversed, 4, and this, that will be a -8 in that case, this one. So it is going to be like this one. It is just like 4 times, you interchange, it will be 3 over 2 like this. So that will be 2, 6. So that will be a -6. This was supposed to be a -3. Okay, guys, it's because here I have interchanged my answers previously. That is the part that affected me, guys, here. All right, no problem. Let me just do it this way. It's not a problem. Let me just do it this way. My preparation, guys, and this what I'm writing is now another way. Multiply. That will be -3 over 2 like this. So this negative, which is 3. All right. And that was going to be a -6 this side. All right. So this is what you can end up with. Just make sure that you also use your calculator. You see these things of not using calculator, guys. Make sure that the calculator is with you. So this is what we have. But this is, in our mathematics, guys, this simplification is awkward. Like, how could we have this? The inequality signs are supposed to be the way that they were here, the way that you were having. They're supposed to face like this, the inequality sign in this format. They're supposed to face one side like this way only. So meaning to say we are forced to do that. So how are we going to rewrite? X here is greater than -6. That is the -6 is the smaller number. You start with the smaller number. So x to that smaller number, it is bigger than. As you can see, this arrow is pointing to -6. So if I rewrite it like this arrow pointing to -6, I haven't changed anything. I haven't changed anything. The arrow is still pointing -6. Here, it is x, which is less than or equal to 3. The arrow is pointing x. So if I rewrite with the arrow pointing x like this, I haven't changed anything also. So it can be like that. So this is your final answer now. You have to rewrite that. All right. So there are so many ways at this stage. Okay. Yes, because of I changed my calculations from the one that I had on my preparation. So let me just do this one so that we can understand each other much better. The same way we could have simplified, just take this 1 to the other side, it becomes a minus. So it was going to be -1 - 1. That's -2, less or equal to -2x over 3 is less than, you take the 1 to the other side, 5 - 1, that's a 4. So if we consider this is over 3, that's a fraction, and you want to get rid of that fraction. So you can multiply by the 3, the denominator there, you multiply by 3 here, you multiply by 3 here. So it's -2 times 3, which is -6. That's -6 less or equal to, remember, you need to get rid of this. So the moment here, it's like you're multiplying also, there's just going to be -2x is less than 4 times 3, which is a 12. Just like that. All right. So that's why you see, guys, I was writing this -6. It was because of this other preparation that I had. But no problem. Let's solve at this stage so that we can also understand both ways of our simplification. There is a -2 that we have, and it's a product. We need to get rid of this -2 so that you have x. So that is where now you have to divide by a -2, a -2, a -2. The moment you divide by this -2, the sign here is changing. So this will be like, it will be like this. -2, -6, and -2, that's a +3. 12 and -2, that's a -6. The inequality sign reversed. So that's a negative like that. Inequality sign is reversed. Then you rewrite, just like what I said on the previous case, to say on rewriting, you are supposed to consider the smaller number first, just like what we have to see. -1 compared to 5, -1 is smaller. So this is the part of the smaller number, this one. -6 is smaller than what? It's smaller than 3. It's a negative, that one. It's very, very small. So x is greater than that -6. Nothing has changed. But the same x is less than or equal to 3. The same x that we are talking about, it is less than or equal to 3. As you can see, it's being pointed. So the inequality sign must point the part where x is. So that is another way that we could have just answered this question in a direct manner. All right, so without this, we're not going to answer this question, so we need that information back. All right, let's just leave it for now so that we can be able to attempt this question. They're saying, write down the number of integers that will satisfy the inequality. Write down the number of integers which will satisfy these. The integers, remember, we're talking of what? These are numbers from. But from where? Is -6 going to be part of our answer? No, because they are saying x is greater than, x is bigger than -6. X here is pointing to minus, it is bigger than. So we are not going to involve minus 6. Minus 6 is not part of our answer. So if minus 6 is not part of our answer, we can simply find the total number of integers by subtracting these numbers. 3 minus 6. That is going to give us what? That is going to give us a positive 9. Just have to add that. Remember, these numbers here, the 0 is there. So it's just 3 minus, which is 9. If it was like this, that there is a greater than or equal to like this, you were going to add a 1 because minus 6 is also involved. So you add a 1. So it will be, you find the difference, then you add a 1. So it will be what? A 10. But in this case, the plus or minus, I mean, this greater than or equal to is not there. So the difference, that one, and let's go on. Or you can simply, guys, these are numbers. X is bigger than minus 6. X is bigger than minus 6, meaning to say we are talking about numbers starting from minus 5. Minus 6 is not to be involved. From minus 5, minus 5, minus 4, minus 3, minus 2, minus 1, top of the 0, 1, 2, 3. How many numbers are there? You can even count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the numbers that we are talking about. The 3 is involved because there is less than or equal to 3. But here, 6 is not taken because X is bigger than minus 6. Minus 6 is not to be taken. So that's another way that you could have taken, or you can just find the difference or just list your numbers. After listing those numbers, count the numbers. How many numbers do we have? The question is not to list, but write down the number of integers. How many integers do we have? On 2.2, on 2.3, solve for X and Y simultaneously. That's a simultaneous equation. Depending with the method that you want, is it going to be elimination? Is it going to be substitution? Whatever method that you want. But it will be easier that you do work with the fraction, with the normal terms, not the fraction that you're given there. So that's our first equation. There is a fraction. Let's get rid of the fraction, guys. We are given x over 5 plus y over 2 is equal to 5. This is the same as 5 over 1. So you just ask yourself, what is the LCD of 5, 2, and 1? That is 10. Or if you do not know, just use the numbers as they are. There's a 5 here, there's a 2. 1 is not important. Don't consider 1. So just multiply by 5 times 2. By 5 times 2. By 5 times 2. Just like that. The 5 and the 5 is going to cancel, remain with 2. So 2 times x, that's 2x. The 2 and the 2 cancels, remain with 5. So that's 5y is equal to 2 times 5 times 2, that's 10 times this 5, which is a 50. So you can even write your equation that way. Or you could have just multiply by 10 by 10 by 10. It's up to you. So this is another equation that we have 2x plus 5y is equal to 50. Just going to have this as our equation 2. So it would depend with the method that you're going to use. Are you going to use the substitution or the elimination method? That part is actually in your hands. All right, so let's start with the substitution method, and then we're going to use another method. So by substitution method, we want to see what is going to happen if we are to do the substitution method. In equation 1, it is easier for us to make x the subject. Also, it is easier for us to make y the subject, anyone that we want. So I'm going to choose x to be the subject. So from equation 1, I'm going to make x the subject. Make x the subject of the formula, meaning to say I'm going to take the minus y to that other side. It becomes a positive. So that's x is equal to minus y on this other side. That's a positive. So it will be 4 plus y, or it will be y plus 4. It's up to you, or you can write it as 4 plus y. It is just one and the same. So this is another equation. You can call this equation 3. We made x the subject from equation 1. We made x the subject. You can make y the subject, whatever that you want, from any equation that you want. But make sure that you substitute in the other equation, not the one that you made not this one, but you substitute in the other equation. So we are going to substitute this in equation 3, in equation 2. So substitute in equation 2 in place of x. So that's in equation 2, there is 2x there. So in place of x, substitute what is representing x now. X is represented by what? Y plus 4 plus the 5y that we have is equal to 50. Let us solve. So we're going to multiply 2 times y, that's 2y plus 2 times 4, which is 8, plus 5y is equal to 50. Collecting the like terms, you can see that there is the part of y here, these are like terms. So 2 plus 5, that is 7y is equal to, we can transpose the 8 to the other side of the equation. It will be a minus 8. It was a positive there, so here it will be minus 8. So that's 50 minus 8, which is 42. Simply divide by 7, both sides. That is, we are going to obtain the value of y there, where y is equal to 6. Just like that, y is equivalent to 6. With this value of y, we can substitute in any of these equations, equation 1, equation 2, equation 3, to find the value of x. But as we can see, it's easier for us to substitute in equation 3 because already x is the subject there. So substitute in this equation, x is equal to the value of y, which is what? 6. So 6 plus 4, that's x is equal to 10. So thus we have solved this simultaneously by using the substitution method. So like I said, guys, there are so many ways. You can also use your elimination method, any method that you do understand as long it is part of your syllabus. So let's also try the elimination method after rewriting those, after having removed our fractions. Remember, this is what we have after removing the fractions. Let's try to use elimination method. So by elimination method, you can eliminate any part. You can eliminate the part of x. You can eliminate the part of y. So in this case, there is nothing that is common. We cannot say x is easier, y is easier. It's up to you. It's in your hands. It's up to you. Which part are you going to choose first to eliminate? So in this case, let's say I want to eliminate x. I have to make sure that the part of x is the same. So here there's a 1, here there's a 2. How can I make these two to be the same, 1 and 2? I just have to interchange. 2 multiplies on top, 1 multiplies below. So that just like that. So multiply equation 1 by 2. That's what I'm trying to say. Multiply equation 2 by what? By 1. If you multiply this by 2, you'll see that that will be the same. Let's multiply 2 times 1. Everything, 2x, 2 times minus y there, minus 2y is equal to 2 times 4, which is 8, each and every term. By 1 also, this one, each and every term, 1 times 2x, which is 2x, 1 times 5y, which is 5y is equal to 1 times 50, which is 50. This is what we have. As we have multiplied, interchanged these numbers, we can see that the part of x is common now, 2x and 2x. We can eliminate this. How? Are we going to add these two so that we remove that, or we are going to subtract? So that is going to be subtraction. If the signs are the same, simply subtract. You want to get a 0 there. So we subtract. So that's 2x minus 2x, which is a 0. We have eliminated x. The same sign that you have used is supposed to be used throughout. So it's minus 2 minus 5. So that's minus 2y minus 5y. Minus 2 minus 5 is what? Minus 7y is equal to 8 minus 50. 8 minus 50, that's minus 42. So we can divide by a negative 7 by a negative 7 now to obtain the value of y, which is y is going to be what? A 6. After obtaining this value of y, now you can substitute this part. Yes, you can go back here and have your elimination redone here. You can have that part of elimination redone. Or you can just substitute in another equation or any one of these equations. So I can even use the first equation X minus y is equal to 4. Remember, when we eliminated x, we obtained the value of y, so we have y now. So x minus y, which is 6, is equal to 4. So what is the value of x? Transpose the minus 6 to the other side, it becomes a positive 6 there. So meaning to say that's 4 plus 6, which is what? Which is equivalent to 10. So that is the value of x that we are going to have if y is equal to any part. So the solving part, guys, of these equations is actually in your hands, the way that you're going to solve this equation. So this is our question number 2. So question number 2. We just have to work as much revisions, do as much revisions as you can, make sure that you understand this part, guys. So if we are to consider on question number 3, that is 3.1, we are given your friends, Zain and Letty, have been trying to solve an exercise based on the following sequence. Remember your number pattern. So that is a sequence that was being given. On 3.11, they're saying, Letty says the answer is that is the answer that is having there for n minus 2. That is the answer for Tn, the nth term. Remember when you're calculating your nth term. And Zain says the answer is this. Who is right? That is a question. A question you are being asked. Who is right? You are the one who is supposed to write who is right between these two. Use algebra to justify your answer. All right. If we are to use algebra to justify our answer, it is just a matter of to say, are these answers the same? But before we look into that algebra part, can we have an answer as on our own? What is supposed to be our answer? What is supposed to be your answer before you test these ones to say, are these answers the same? You as an individual, what was going to be your answer in that case? If you are given a sequence of 2, 6, 8, 14, and so on and so on. So we just have to try our linear first. Are there differences that are the same? Are there differences that are common? Okay, as you know, this is your first term, your second, your third term, and so on. So T2 minus T1, that's to find the common difference. This one minus this one, we have got a difference of 4. Term 3 minus term 2, that is 8 minus 6. What are we going to have there? Okay, this is 10. Where am I getting this 8? This is 10 here. All right, this one. That's a 10 there. So that's 10 minus 6, which is going to give us a 4. Do the same thing, 14 minus 10 here, which is a 4. So you can notice that the difference is the same. We have a common difference. So this is referred to as a linear sequence that we have there, a linear pattern. How do you find Tn under a linear pattern? We understand that Tn is equal to, there's so many ways, guys. I talked about this of Bn plus C. If you want to apply this, as long you understand this one, we're going to have different ways as we proceed in our grade 11 and so on. Where B is the common difference, as just, you know, this will be your common difference, your common difference. And C is the value to be determined. So it means Tn is equal to B, our common difference, which is 4. So that's 4n plus C. So to find C, you can use any part, like T1 is 2, T2 is 6. You can just use any part. So if, like what we have there, if T1 is equal to 2, what does it mean? Remember, this is Tn, n, in place of n there. What is representing n? N is represented by 1. So it means n is equal to 1. So if you say T2 is equal to 6, your n is supposed to be 2. In place of n here, you're supposed to put a 2. So you're saying Tn, T2. So that is what we have, like, in that case. So in this case, if we are using T1, I'm going to use the first one. You just use any one. You are going to have the same answer there. So if T1 is equal to 2, it means here Tn, we are going to write it as what? As 2. T1 is 2. So T1 is equal to 2. N is the one which is 1, where there is N here, where there is N. But the whole of Tn like that is T1, which is what? Which is 2. So it is equal to 4 times N. Remember, we said N is 1 plus C. So 4 times 1 is 4 plus C, and we can take this 4 to the other side. That's 4 from 2. 2 minus 4, which is minus 2, is equal to C. So therefore, our Tn was supposed to be written as 4n. This part you rewrite as it is, plus C. Our C is minus 2. So that will be Tn is equal to 4n minus 2, like that. This is how our answer was supposed to be like. So if we cross-check who is having this answer here of 4n minus 2, we can see that Letty is having that same answer, which is correct. What about Zane? Can we say the answer for Zane is not correct because it is not written like this? No. Let's try to simplify it. That is where the algebra is playing a role, to say if we are to simplify the Tn, this one, for Zane, is it going to give us the same answer as we expect it to be for n minus 2? Are we going to have that same answer? So we are given 4 into n minus 1 plus 2 like this. Let's expand by distributing by 4, 4n. That is 4n there, 4 times minus 1, which is minus 4 plus 2. So that is going to give us 4n minus 4 plus 2, that is minus 2. This is your Tn. 4n minus 2, which is the same answer. So these guys, they're both correct. They're both correct. No one is wrong. So in this case, due to our algebra, you can see that is the same answer. So both are correct. Both are correct. They have the same answers there. You're having that same answer, which is our Tn. And using that 3.12, it's a continuation now. Determine the value of the 27th term of the sequence. The 27th term of the sequence, it means n is equal to 27. N is equal to 27. So the 27th term is T27 in place of n. N is 27. So we just have to substitute n, which is what? Which is 27. In place of n, you are going to already, this is your answer. You can substitute in this one. You can substitute even in this one. Here, in place of n, you substitute that 27 here in this one for Zane. You're going to have the same answer. You're going to have the same answer. Remember, these two, they are both correct. So whatever that you're going to substitute there, you're going to have the same answer, which is 106. That's the 27th term of that sequence. That was the question on 3.1. Consider 3.2. A continuation again, still on the sequences, working with the sequence. That's another sequence to be considered. Minus 3, we are given this minus 3, 2, 7, 12, 17, and so on. So just first try to have it as a linear and see if it is going to be a linear. Then if it is not, you try another one. So they were given 3.21, determine the nth term, just like what we had here. That is the nth term. This one, writing in form of this Tn is equal to n. That is what they're asking you to do. So we had this similar question, guys. Is it a linear pattern? Let's try the difference, because this is the first term, the second term, the third term, and so on and so on. So we subtract 3 minus, it's like this, 2 minus this, minus 3, like this. 2 is subtracting minus 3. So it's 2 minus what? Minus 3. That will be a plus. So 2 plus 3, that's a 5. So there's a difference of 5 here. We subtract again. 7 minus 2, that's a 5. 12 minus 7, that's a 5. 17 minus 12, that's a 5. So as you can see, the difference is the same throughout. That's a linear pattern. The same way, or the same part that we had in our previous question, it was a linear pattern. And I said on a linear pattern, you can use this simpler one. Tn is equal to Bn plus C, where B is the common difference, which is our common difference is 5. So that's 5n plus c. So c is the value to be calculated using any way that you understand. If you understand this, like I said, T1 is equal to what? T1 is equal to minus 3. So in place of Tn, T1 is minus 3, where this represents n, the 1. So it means n is equal to 1. In place of n, you are going to substitute a 1 plus a c. Any part you can use T2, which is 2. You can use T3, which is, as long as you understand that T2 is equal to 2. So this is what you represent in place of T. But in place of n, you represent a 2. T3 is equal to 7, like that, like that. You can still find the same value of n. 5 times 1, that's a 5. You take it to the other side, it becomes a minus. So it's minus 5 here, which is equal to c. Minus 3 minus 5, that's minus 8, is equal to c. So therefore, our Tn was going to be written as 5n, which is our first part, plus c. Our c is what? Minus 8. So plus and minus, guys, that's a minus. So that'll be a minus 8 at the end. So this is what we are going to use in whenever you want to calculate for the nth term of this expression, of this sequence, we are going to use this expression that we have simplified, or that part that we have there. All right. Then on this question, it was an interesting part. We have to be very careful here because they are saying, if you take a closer look here, they are saying determine the value of the 52nd number to end in a, take note, to end in a 7. The 52nd, to end in a 7. We are not going to substitute this 52 here and we just take it and say, okay, this is our Tn, so substitute 52. No. Because this sequence is not the one that they are talking about. They are saying it is supposed to be ending in a 7. The sequence is supposed to end in a 7. All right. So meaning to say, if we consider properly, we are going to see that in this sequence that we had before, there's a part of a 7 here. If you check, there's a 7, a 17, another part where a 7 was going to be, it was going to be a continuous 27, 37, and so on and so on and so on. Where it ends with a 7 like this, 7, 17, 27, 37. It ends in a 2, so it's supposed to be 2, 12, 22, 32, and so on and so on. So it's a new sequence that is to be brought about here. We now have a new sequence to consider which ends in a 7, because the numbers are supposed to be 7, 17, 27, 37, and so on and so on. These are the numbers which ends in a 7. End in a 7. So the value is the 52nd number that we need. So definitely, guys, we need Tn again. So according to this new sequence, it's a new sequence, this one that we now have, guys. It's a new sequence that you now have. So find Tn, just like what you did on this part. You determine the Tn out of that sequence. So determine again another Tn. With that Tn, you can find the 52nd number. So what will be our Tn? Let's find the difference. T2 minus T1. Remember, this is your T1 now. This is your T2. It's now a new sequence to be considered. What is the difference? 17 minus 7. There's a difference of 10. 27 minus 17, a difference of 10. This one, a difference of 10. So as we can see, we still have that linear sequence that we had before. So our Tn is supposed to be Bn plus C, where I said B is now common difference, which is what? 10 plus C. So to find C, just use any part, guys. You can use T1. You can use any part. So T1 is equal to what? According to this sequence, our T1 is 7. Remember, it's a new sequence that you have to consider now. So if T1 is equal to 7, it means in place of T, there we are going to substitute a 7. And in place of N, like T1, 1, this one, N is the one that represents 1. So N is 1 there. So that's 10 times 1 plus C. 10 times 1, that's 10. Take it to the other side, that's a minus, which is equal to C. So 7 minus 10, that's minus 3, which will give us a C. So therefore, Tn of this sequence was supposed to be given as 10n minus, remember, that's plus and minus. So it's going to be minus 3 like that. This is the new Tn to be used to find the 52nd number of this sequence, which end in a 7. So what is T52? That is our question now. What is T52? In place of n is now 52. 10 times 52 minus 3. The answer is also supposed to end with a 7. So that was going to give us 517. If that answer is not ending also with a 7, it means we are using a wrong formula for a wrong sequence. So that is how our questions can be given. As also this one, you can have it in different ways. There are so many ways, guys, of answering these ones. You just have need of time to work with different ways, approaches that can be used. On question number 4, working with your functions, you are given on question number 4, the sketch below shows f of x, which is a to the exponent of x minus 3 and also gx. So there is f of x here, which is a to the exponent of 8, this and that, which is important for you to have as we are given our exponential function there. Then the g, it's a hyperbola, which is also given. So the part of f, we can also see on this f, the asymptote is given, minus 3. That is the part of the asymptote. In place of g, the asymptote is taken there in place of what? Minus 4. We have got all these. So that is important for us to note. The asymptotes here, minus 3 and the minus 4 respectively. Then you're also given the point A. Okay, then is a point on F, and B is a point on what? On G. So B is a point on what? On G. C is the x-intercept of the graphs. C is the x, this one. C is the x-intercept for both graphs that you're given. So with this dotted line that you're given, they are showing us this is a straight line, meaning to say it's a parallel to the x-axis, meaning to say we've got the same value of x, the same value of y at that point. Okay, we shall see about that in our revision. So this is our diagram. Let's consider the questions and see what we're supposed to answer there. 4.1. Write down the domain of f on 4.11. The domain of f as we consider f of x. What is the domain? When you consider the domain, what are we talking about? What is it that you are referring to? The domain, these are the limits of x, the limiting value of x, to say our function as it is to consider x values. Is it going to be affected in terms of the x values? This function of f, in terms of these are the x values, guys, these ones. Are they affected? The x values, guys, they can be taken from negative infinite up to positive infinite, up to the end. Not affected. It is y which is affected, that it cannot reach minus 3. It's an asymptote there. But x is not affected. X can be any value. So meaning to say, if these are x values, x, since it is not affected, it can be any element of the real numbers that we have. As long it is a real number, we can have it as our answer. X is not affected on that part. So that's the domain of f. 4.12, they need the range of what? Of G. We are now considering G, the range of G. Range, we are talking about the Y values now. Range of G. These are Y values. So the Y values, they are simply taken, guys, from the asymptote, because we can see that if they are saying this is the asymptote at minus 4, where Y is equal to minus 4. Our graph is not going to reach that minus 4. It is not going to, so it's not supposed to be like this. It will be tending to approach this value, but it won't approach. So meaning to say, the values of y, they are affected from this minus 4. Where is our function? Is it down or is it on top? The function that we have of g is on top. We're talking about these values on top. -3, -2, -1, 0, 1, 2, 3. Compared to -4, how are these values? They are bigger than -4. They are greater than -4. These -2, -1, 0, 1, 2, 3 going up. They are bigger than -4. So y is greater than -4. Or you can just take from -4 up to infinity, no matter the way that you want to present that way. The equation of the asymptote of f, the equation of the asymptote, considering f, we can simply take it here. The asymptote is already there. Y is equal to -3. Or you can take it from the graph, the asymptote, where the graph of f is limited. Remember, this is the graph of f, this one. It is limited where? At -3. So that is our asymptote for f. Y is equal to what? -3. So for f, asymptote is limited. So that's 4.13 at y is equal to -3. 4.2, show that a is equal to 3 to the exponent of -1. A is 3 to the power of -1. How can we show that? A is on f. If we check this properly, A is found on what? On f, where we are given f of x is equal to a to the exponent of x -3. When we say f of this one, these are y values, this one, y versus x. So instead, I can just write this. Instead of me writing f of, I can just write as y is equal to a to the exponent of x minus. That is what it means. So if this is y and this is x, is there a point which lies on f that we are given and it's a complete point? Yes, the point is there. Remember, a is a point which lies on the graph of what? Of f. So using the point a, or taking advantage of this point a, which is given as -26, they gave us the x value, they gave us the y value. So it's a point which is found on the graph, just like what you had in your grade 8 mathematics. A point which is found on the graph satisfies the condition of the graph to say, in place of y, we are going to substitute 6. In place of x, we are going to put -2, x and y. So y is 6, where our x is what? Our x is -2. So that's it. This is -3. There's no substitute there. Remember, we need to show that a is equal to 3 to the exponent of -1. All right, no problem. So let's take this to the other side. It becomes a positive. There it was a minus. You transpose this, that's a plus. 6 plus 3, which is equal to 9. So 9 is equal to a to the exponent of -2. This is where we are. We need to find the value of what? The value of a, guys. We need the value of a. And this one is a to the exponent of -2. So how do we remove this exponent of -2? The one that we are given there. Opposite of this. That is a -half. It's supposed to be a -half. The reciprocal, the inverse of -2 is what? Is -half. So that if you multiply -2 and -half, what are you going to get? You're going to get a 1. So you just have to find that reciprocal. So this is the same as we have got 9, which is equal to a to the exponent of what? -2 raised to the exponent of -half. The moment we use this -half, we are supposed to also use -half this side. To remove that exponent, you find the reciprocal. So 9 to the exponent of -half is what? On your calculator, you can even use your calculator. 9 to the exponent of -half, that's 1/3. So you're going to get 1/3, which is equal to this one, and this one, guys, was going to cancel. You get a to the exponent of what? A to the exponent of 1, which is 3 to the exponent of, which is 1/3. But 1/3 is same as what? 3 to the exponent of minus 1. Remember your laws of exponents. X to the exponent of minus 1 is 1 over x. X to the exponent of minus n is 1 over x to the exponent of n. So here we've got 1 over x, the reverse, to the exponent of minus 1. 1 over 3, the reverse, 3 to the exponent of what? A negative 1. So this is the A that we're being asked to show. So many ways that, guys, to solve this, this one, there's so many ways. We can even at this stage where we have this 9 here from this stage, 9 is equal to a to the exponent of minus 2. We can write this 9, or we can change this a that we are given there, remove that negative, it is 1 over a squared. To remove that negative, this is same as over 1. So you can cross multiply to remove the fraction. 9 times a squared, which is 9a squared, is equal to 1 times 1, which is 1. Divide by 9, divide by 9. In that case, you need to find the value of a, remember? So this will cancel. A squared is equal to, okay, divide by 9 there. That's 1 over 9. This is a squared. And what you need is a, not a squared. So introduce the square root to remove the square that you're given, or to the exponent of a half. It's up to you. So a was going to be the square root of this, which is 1 over 3. And once we have 1 over 3, we have got a to the exponent of minus 1. Or maybe you do not want to introduce the square root. You just ask yourself, what is the opposite? What is the reciprocal of this half? A half, the reciprocal is 1 over 2. So you raise this to the exponent of 1 over 2. You also raise this to the exponent of 1 over 2. So this can multiply, and you have got a 1 over 2. This 1 over 9 raised to the exponent of 1 over 2 is still simply 1 over 3. And if that is 1 over 3, it means we've got 3 to the exponent of what? Minus 1. So simplifying there later on, guys, is actually in your hands, the way that you understand in your simplification. That is the value of a that we wanted there. Determine the coordinates of C. Where is the point C? We were told that C is the intercept, x-intercept for both of these two graphs. It is the x-intercept of the both functions. So C can be calculated from G. C can be calculated from F. You can use anything because it is on both. So if we check on F, our equation is complete in F. So you can just take that advantage of what? Of G. I mean, this one on G, this one. We've got everything. Yes, you can even use that F. It's not a problem. But you can even use G from GX. All right. So that's 4.3 from what? From G of X, which is equal to minus 4 over X minus 4 like this. Remember, I said it simply means Y is equal to this. So remember, we need the value of X. It is the Y value that we know because we are in the X axis. Remember, in the X axis, guys, remember these two, the X axis and the Y axis. In the X axis, we know that Y is equal to 0. And in the Y axis, X is equal to what? To 0. So if as long as a point is found in the X, as long it lies in the X axis, Y will be equal to 0. So you can take that as an advantage. Y is equal to 0. So that's minus 4 over X minus 4. So simply solve for what? Solve for X. We need the X value to make, or to have a point, we must have the value of X. All right, minus 4 to the other side, it becomes a positive there, 0 plus 4, which is 4. So 4 is equal to minus 4 over X. How do we find X? Simply cross multiply 4 times X. That's 4X is equal to 1 times minus 4, which is minus 4. We can divide by 4. We can divide by 4. So X will be equal to what? A minus 1. So that is the value of X that we have here. That's a minus 1. So as a point, the coordinate now of the point, you say, remember, a point is made up of X followed by Y there. So we now have the X value, which is minus 1 at a condition where Y is equal to what? At a condition where Y is equal to 0. Remember, X-intercept concept. So that's our point C. You can just have our point C that way. Minus 1, 0. just like that. Not to say if we were to use the part of f, we're not going to have this. We're going to have the same answer. Remember our f of x, we calculated the value of a, so you can also determine from f of x. Remember f of x is equal to a to the exponent of x minus 3. And we calculated this a, and we said a is what? Remember, we got a is equal to 3 to the exponent of minus 1 from our previous calculation. So it is 3 to the exponent of minus 1 raised to the exponent of x. So it's 3 to the exponent of minus 1 to the exponent of x. Exponent times exponent. So it will give us minus x there. And we've got minus 3. So this is what we have. We can use that. And the same concept, because there it is the same thing. It is the x-intercept. So it is the y that we know. That y is equal to what? Y is equal to 0. So if y is equal to 0 here, what is the value of x? That is the question. What is going to be the value of x? All right, let's take the minus 3. It does not affect. To this side, it becomes a positive. So thus 3 is equal to 3 to the exponent of minus x. How do we find x? Because we need to determine x there. Already, if we check properly, we can see that these bases are the same. There is no way, guys. We know that if the bases are the same, to say there's a 3 here, the exponents are supposed to be equal also. So 1 is equal to minus x. So if 1 is equal to minus x, what is the value of x? Divide by -1, divide by -1. Our x was going to be minus 1, which is the same value. So C will be minus 1, 0, as we had from our previous calculation. Any way that you want. Any part that you want. You can use that f because already you have the value of a. So f, you have that part of f. They can ask questions like that. Write down the values of x for which gx is greater than f of x. Gx is bigger than, that is what they are saying there. That is what they are saying there on 4.4. Gx is bigger than f of x. You just have to check where is the graph of gx on top of f of x. Because it is the one that is bigger. So we need where it is on top. Where gx is found on top of f of x. If we check here from this side, or this side here, from this side, when we with these values here, this is your gx. Your gx is this one. Compared to f of x, look where f of x is. Up to the point you see here. F of x is the one that is above. We can see it's on top. Not gx. Gx is below. So from this region of -1, where we have -1 here, going this side, -1, -2, we do not have our answer there because it is in the opposite manner of what we want. We want gx to be the one on top. But the moment we move from that -1 going to this right side, we can see that gx, this f of x, we can see this or f of x, compared to that gx that we had, this our gx, we can see this is our gx. Gx is the one that is above, on top. It is the one that we see on top. So it is happening from this -1 going to the what? To the right side. Meaning to say we're talking about -1, 0, 1, 2, 3. These are the values that we're talking about. Compared to this -1, how can we write these values? What are we saying about this x? X is bigger than -1. X is greater than -1. These values, they are not saying equal to. If they put an equal to here, you also have to put an equal to there, but they are not having that. So please don't put that. It is just going to be greater than. So all these values of x, which are bigger than 1, we are going to see that the graph of g is going to be on top. It is going to be greater than. Which was the opposite. Now, if maybe they said gx is less than f of x, we need where it is below, this side here, where x is compared to -1, -2, -3. where x is less than what? -1. So answer the question properly. Examine your graph, understand your graph, what is given on that graph. Understand your graph, the information that you're given on your graph. That in that way you can answer any question that you are being given there. All right, let's consider another question. Also here, let's see, because another thing to consider, guys, here is that if we check here on G, because G is not done, let's check the asymptote. On G, the asymptote there is what? Because we have to consider that also. In this graph, it cannot exceed this, it cannot go above this point. It cannot reach like this point where we are moving this side 1, 2, because x there is just x. So it's an asymptote also where x is equal to what? Where x is equal to 0. When we are dealing with a asymptote of what? With a asymptote of G. We are supposed to consider that. We talked about the asymptote, okay, it was of F. When we consider the asymptote of G, we are supposed to also consider x, which is 0 there. So if we consider x, which is 0 there, meaning to say our graph is limited now in between -1, and also it is supposed to be less than that 0, because it is not supposed to reach the 0. So how can we write this in a simpler way, guys? We can just write it as x is greater than -1, but less than a 0 like this, but less than a 1. The asymptote there. This one, it is not like it is forever in values of x. No, it is limited also to the initial part of our x, which is what? Which is at 0 there. So you're supposed to also consider that in your final answer. All right. So those are some of the things that you also need to be very, very careful as you are answering your questions. 4.5. Determine the equation on 4.51, the straight line through A and C, the equation of the straight line through A and C. They want you to find the equation of the straight line between A and C. You're given the points there. A and C. That's 4.51. So in order for you to have the this equation that passes through A and C, you must have the point A and also the point C. So they are there. You're given. The point A is given, -26. The point C is also given. Remember, we calculated this. We said it's -1 in the x-axis. Y is equal to what? Y is equal to 0. So finding equation of a line, we need the gradient, where we can consider x1, y1, x2, y2. Remember, your gradient m is equal, y is equal to mx plus c. Remember your equation. So m is the gradient. The change in y over the change in x. y2 minus y1 over x2 minus x1. So y2, that's a 0 there, minus y1, which is 6 over x2, -1 minus x1, which is -2. Just use your calculator, guys, to simplify this. You are going to obtain a -6. This is our gradient, the gradient that you're supposed to substitute in place of m. So y is equal to, in place of m, -6x plus c. Just like how you were solving those sequences. So how to find c? You can just use any point. You can use this point of -2 versus 6. You can use -1 versus 0, any point that you want. Let's say you use -1 versus 0. You are given x and y value. To say that y is equal to what? Y, the y value you are given, that is what you're given there. To say at this point, y is equal to 0, when x is equal to what? When x is -1. You can even use the first point, whatever that you want. You are going to have the same answer for C. So that's 0 is equal to -6 times -1. That's a +6 plus C transpose the 6 to the other side. It becomes a negative there. So that's -6. 0 minus 6, guys. That's -6. is equal to what? Is equal to C. So therefore, the equation of the line is given there. So therefore, y is equal to minus 6x plus C plus this minus 6 that we are given. So the equation was going to be 6x minus 6. We can use any, like I said, any point that you want. You can even use the first point. It is still one and the same thing. All right, 4.52, the axis of symmetry of G with a negative gradient, the axis of symmetry of G. All right, let's consider our function G. All right, so that is what we need here. Let's just remove this one and see what is going to be our equation. So they need the axis of symmetry of what? Of G with a negative gradient. Axis of symmetry of G. This is G. So remember, the axis of symmetry is simply an equation of y is equal to mx plus c. But that y is equal to mx plus c, it is easier for these because it is going to be either x plus c or it can be minus x plus c. These are the only two types of equation that you're supposed to expect when they talk about the axis of symmetry. So one, it has a positive gradient, the first one, where the sign is not given. This is the one of the positive gradient. When they talk about the one with the negative gradient, this is the one that you take. So we're going to use this one because they talked of what? Negative gradient. So we're going to use y is equal to minus x plus c. These are the only two formats, whether you are in grade 11, whether in grade 12, they are not going to change. These are the only two formats to find the axis of symmetry. Where the value of C now, for you to find this C, you need the point where we have what we refer to as those asymptotes now. Part of our asymptote for G. So remember G, what is it that is affecting on our asymptote for G? G is this function. The asymptote is affected. Remember we said that x is equal to 0. I mentioned that. And also another asymptote is at what? Minus 4. So that equation of the asymptote, the point, the minus the 0 there and the minus 4. X is 0 and y is what? Minus 4. So you take that point of 0 minus 4 for the asymptote. X is equal to 0, y is equal for those asymptotes. That is the one that you substitute. As you can see, I've got x and y. So y is what? Minus 4 is equal to minus x. X is what? X is a 0. So guys, minus 0 times any number, that's a 0. So it means minus 4 is equal to c. So if minus 4 is equal to c, we have got our equation, guys. Y is equal to what? Minus x as it was, plus the c, and the c is what? The c is minus 4. So plus and minus there is just going to be a negative. That's how you determine the equation of the asymptote. So if they said with a positive gradient, you were going to use y is equal to x plus c. You substitute that same asymptote there, the same way that you did here. That is the one of the positive gradient, but we need the one of what? The negative gradient there, supposed to be minus x. So those are some of the questions that can be asked. Then on 4.6, if AB is a horizontal line, calculate the length of AB. If we are to consider AB as a horizontal line from our graph, we saw that A and B, this is where we have it here. If it is to be taken as a horizontal line as it is presented here, what is the effect? What is that we are going to take? It is the same value of y that is not going to change here. It is the same, the value of y. So on A here, the value of y is what? Is 6. It means also here the y that we have is 6. So also at point B there, what we do not know is x, but what we have or what we know is that y is not going to change. Y is going to remain as 6. That is the idea of what? A horizontal line. Y is the same. If you consider vertical line, if it is a vertical line, it is the x value, which is the same. If this is 2, 6 like this, it means at this point, we are going to have 2, but the value of y is the one that we do not know. But 2 is going to be the same for x. It's a vertical line. X values are the same. So on a horizontal line, the y values are the ones that are the same. Y is not going to change. Y is not going to change. So if y is not going to change, guys, it means at point B, y is equal to 6. So if at point B, y is equal to 6, it means point B is given as x 6 like this. Because remember, a point is given x followed by y. So we can determine this value of x from G because B lies on what? On G. What is it that we have on what? On G. So from our G of x, which is equal to 4 over x minus 4. Just like the previous case, guys, when you know the value of y, you can find the value of x. So if y is equal to 6, it means gx, remember I said gx simply means y is equal to. So you know that y is 6 there. So 6 is equal to 4 over x minus 4. You need to find the value of x when it is like that. Just like that, guys. Solve for x. Take the minus 4 to the other side. It becomes a positive there. That's 6 plus 4, which is 10. So 10 is equal to 4 over x. Cross multiply so that you can have x. 10x is equal to 4. So what is the value of x there? At this point, we can simply divide by 10 both sides. So x was going to give us 2 over 5. Or you can actually have it as a decimal, which is which can be a decimal if you want. All right, was this positive? Let's check, guys. This yeah. All right, see, guys, this is the issue of being tired. So this is supposed to be a negative, yeah, isn't it? Here it's minus 4. There's a minus there. I forgot to place the negative there. There's a negative here. So it was supposed to be negative. I hope someone saw that and corrected. That's a minus. Here it's a minus. Here that's a minus. So that's a minus. So you can have your answer as minus 2 over 5, or you can have it as a decimal, minus 0.4. That is the x value that you are having there at this point. At this point here, we have got the x value there at this point. The x value is minus 0.4 or minus 2 over 5. So what is the distance now? Calculate the length. If we know that x there is minus 0, remember the issue of a horizontal line, guys. It's like this. This is what I want you to take note on a horizontal line. Remember, we have got x, which is important. You can use the distance formula. It's up to you, that one, using a distance formula. But this is the idea of a straight line. When you are given a horizontal line, just work with the x values. The x here at A is minus 2. The x at B is minus 0.4. So the difference, the distance there is the difference between these two. The difference, whether you're going to subtract this way, whether you're going to subtract the other way, the difference between that is the distance. The difference between, so you can even ignore this. There's a this one is a negative, guys. This one is a negative. You can ignore those negative. The difference is the one that you want. So what is the difference between these two? That is the length of AB, which is simply 2 minus 0.4. So 2 minus 0.4, that is 1.6 units. So you've got the distance between A and B. But let's say you do not understand this. You can even use your distance formula. Remember your distance formula. You have got your A, which is what? Minus 2, 6. You calculated this. You now have the value of at point B. You remember you calculated your X and got minus 0.4. And the value of Y we said is already at what? At 6. Remember, that's a horizontal line. So Y is not going to change. Y is going to remain at 6. And you can use the distance formula if you want. That's another way. The distance of AB is not going to change. X2 minus X1 squared plus y2 minus y1 squared from your distance formula, where you have got your point. This is x1, y1. This is x2, y2. So you're going to substitute our values there. X2 minus x1, or x2 minus 0,4 minus x1, which is minus 2. So that's a minus 2 like this squared. Plus y2 minus y1. Y2 is 6. Minus y1, which is also 6. You square this. You are still going to obtain the same answer of 1,6 units. So calculating of that distance is actually in your hands. So you can have that distance another way. Okay, that was our question 4, the wall of 8. And question number 5, quickly rushing through this one. They say, consider a quadratic function h with the following characteristics. The axis of symmetry is the y-axis. All right, they want us to sketch this. So you can actually sketch this, guys. All right, let's see. They're saying it is like this. We're just going to need our y-axis and x-axis. Let's just say we've got something like this. And this is our x-axis. So this is just a sketch, but you just try to draw something that is proper. That in this case, I'm just going to have a sketch. So they said it is passing through, it is the axis of symmetry, which is the y-axis. So the y-axis is the axis of symmetry. So our graph is simply divided into 2 equal parts. It's either like this or it is either like this, but it is divided along the y-axis. That's what they are trying to say. So for now, we cannot know because we do not have any other information. Let's move on to another one. The x-intercepts are minus 4, 0, and 4, 0. These are the x-intercepts where it lies in the x-axis. So let's say we've got 0, 1, 2, 3, and 4. This is minus 1, minus 2, minus 3, minus 4. They are saying the another point is minus 4, 0 like this. Another point is 4. These are the x-intercepts. Then the graph cuts the y-axis at minus 8. Where it cuts the y-axis, it is going to cut at minus 8 like this. So this helps us in terms of the shape. We can simply see that the shape of this graph was going to be like this. But being divided into 2 equal parts, as we are told that the y-axis is the axis of symmetry. So it's supposed to show us a half and another half on this side, divided into 2 equal parts. So this is the axis of what? Of symmetry. So they wanted you to just draw this, just to sketch. Clearly show all the intercepts with the axis. This is what we have, the axis, that is minus 4, this and that. 5.2, determine the equation now. Now they want you to have the equation. So when you are given this this condition where the y-axis is given as the axis of symmetry, it is an easier equation for you to find or to determine. Okay, that's hx is equal to ax squared plus q. Q is simply representing a condition where x is equal to 0. Y is what? The value that we have in the y. Because this is, when we say the y-axis is the axis of symmetry, guys. This point that we see, the minus 80, yes, it is the y-intercept, but it is also a turning point there. It is also a turning point. That is where the graph is limited to. So that is the y-intercept. That is going to be your turning point there that you're substituting. So it means your hx is going to be written as ax squared. The q exactly where it passes, the way it crosses the y-axis at minus 8. That is how you can have it. So to find a, you can now substitute any point. You can use now those x-intercepts. Is it this one or is it this one? Any of your choice. You can choose any of your choice. So I'm going to use the positive one so that we do not have challenges there in calculation. 4, 0, or you can use the minus 4, 0. Anyone, any of these. So I'm going to use this x, y there. We are given that y is what? Y is, remember, hx means y is equal to. So in place of y, we are going to put a 0 there. Is equal to a. In place of x, we are going to put a 4. So that's 4 to the exponent of 2 minus 8. So let's solve for a. we're just going to solve for a. Minus 8 to this other side, that's a plus. 0 plus 8, which is 8. 4 squared, that's 4 times 4, which is 16. That's 16a. Divide by 16 both sides so that we've got the value of a. So 8 over 16 simply gives us 1 over 2, or a half. This is the value that is representing our a. So therefore, our equation can be given as h of x is equal to a is what? We obtained 1 over 2 x squared, and our q, remember our q is that minus 8. So this type of an equation, it is easier to work with when the y-axis is the axis of what? Is the axis of symmetry. We just have to use in that format. Write down the values of x for which hx is less than or equal to 0. This is our hx. Where is it that it is less than or equal to 0? They are talking about, remember, in this x-axis, y is equal to 0. So the moment we say hx, it's like we are saying y is less than or equal to 0. Where is it that y is less than 0? This is below this graph here, down this graph, below. In between these values, minus 4 and what? And 4. So this one was straightforward, guys. X is going to be greater than or equal to minus 4, but less than or equal to what? But less than or equal to 4. All right, where hx is less than or equal, there is an equal to. So our answer, we are supposed to have that equal to is supposed to be there on your answer. Then on another question, they want you to write down the equation of k if kx, it's another question, this one. It's another question. Kx is equal to minus hx minus 6. They are saying form an equation. So what is that we just need? We just need to substitute hx, guys. Yeah, in place of hx. They are saying it's minus hx. It's minus that. So it's minus of hx. What is our hx? Remember, you solved or you calculate this hx. You substitute that, but put a minus. So that's half x squared minus 8. After this, multiplying hx with a minus, whatever that you're going to get, we are going to subtract a 6 there. That is what they are saying. So let's expand by minus. Distribute this bracket. Minus times half x squared. That's minus half x squared. Minus times minus 8. That's a plus 8. And there is a minus 6, which is remaining. So that is going to give us minus x squared 8 minus 6. 8 minus 6, that's a positive 2. We have an equation representing the new function of kx. That is what our question was all about. So when you're given this type of a question, just use the way that you're given. They can write maybe kx is equal to 2 into hx minus 1 or plus 1, whatever that you have. Substitute your hx from what you're given. Then after that, simplify as far as you can in terms of the simplification that will be given there. That was your question number 5. This is what we had. So let's consider the other part, which is on question 6. We are given on question number 6 that Ami needs to buy a new computer, but the computer costs 7,990 Rand. Then Ami does not have the full amount of money available. So she decided to enter into a hire purchase agreement. And the terms of the agreement are as follows. This is what we have. 15% per annum simple interest. 48 monthly payments to be made. 48 monthly. How many years do we have? Divided by 12. Just like that. Divided by 12. Meaning to say, we are talking of what? 4 years. The terms, these are the terms. Then the monthly processing fee, monthly processing. Supposed to be that. Determine the monthly amount payable, including interest and fees, including the interest and fees, everything. What is supposed to be paid on a monthly basis? So this is it, guys. Remember, when you are now paying, it's like you are paying a loan. It's just like a loan to say this amount is going to increase, but this is under a simple interest. The laptop was supposed to be 7,990. So let's talk about the amount to be paid in 4 years' time before we talk of what is to be paid monthly. Let's talk about the amount to be paid under this hire purchase. So remember that under hire purchase, we use what? Simple interest. We use the simple interest. So the principal, that is the cost that you are given, 7,990, 1 plus the interest rate. Remember, it was 15% per annum, that is per year. So 15 over 100, which will give us 0.15 as a decimal. So that's 0.15 times n. This is the number of years, not the months. We use the number of years there, which is 4. So that was going to give us a total amount of 12,784, which is to be paid in 4 years. To be paid in what? In 4 years, in 48 months. In terms of the months, these are 48 months. Remember, the 48 months is the 4 years. So if this is the amount to be paid in these 48 months, what about monthly? What is this person going to pay in a monthly basis? So monthly, it is going to be that amount to be paid over the period of 84, over the period of 48 months. Divide by 48, you've got monthly. That's the idea there. But they said we are supposed to involve all these, including the interest, the fees, every fee that is there. There is a monthly processing fee, which is there, 13 Rand 50. Monthly, that is what is written there. So it is supposed to be added on monthly basis. There's a monthly processing fee. So this is what you're going to be paid monthly. So you are supposed to pay, it was supposed to be 266.33. Then we add that monthly processing fee. So together combined, that will be an amount of 279.83 Rand. That is the total that is to be paid monthly, in each and every month. Just like that. Then on question number 6.2, they said, on his birthday, on his 29th birthday, John invested. It was now an investment, this one. Okay? On the Johannesburg Stock Exchange. His shares increased in value by 20% compounded annually. That's a compound interest annually per year. How would his investment be worth on his 60th birthday? So the question is, he invested 5,000. That is the principal amount. 5,000 amount invested. On his 29th birthday up to the 60th birthday, what is the number of years and counted? That's 60 minus what? 29. Remember, if you talk of birthday, these are years. So the difference there, those are the years that are going to be taken. So 31 years. We're talking of N being 31 years. 31 years. How much would this, okay, there is an interest compounded annually. So 20 divided by 100, that's 0.2. This is annually compounded. So that's we are using the compound interest formula to calculate that amount. So amount under compound interest, remember that's P into 1 plus I to the exponent of N, where the amount is P, the principal, which is 5,000 into 1 plus the interest rate, that's 0.2 to the exponent of n. How many years? That is our n, the number of birthdays to be taken in between. That is the one that you need. There are 31 in between. You can calculate it from there. Just use your calculator, guys, at the end. Just simplify this. This is going to be was 5,000. So from this, it was going to give us 1,524,500. Okay, this is 1,524,257,88 to 2 decimal places. This is what you're going to have as the amount accumulated. This is what is going to have after 31 years if the interest rate is at what? 20% compounded annually. So questions can be like that. Just have to be very careful in your simplification. Question number 7, it was a probability for any two events, any two events, A and B. We are given the probability of A and that of B, and the probability of A or B, not A or B. That one is not A or B. Remember that, not. So the question was on 7.11 to calculate the probability of A or B. I remember from the complement concept, guys, or from this not like the if you say complement, the complement is on two events, A and its complement. The probability of this is supposed to be for any set A and its complement. I explained from this is supposed to give us what? A 1. If it is B here, this is B complement. So if I use the probability of A or B like this, plus its complement, this is A or B, it must remain with A or B as it is, A or B as it is, but its complement, we are supposed to get a 1. Whether it is of the intersection, guys, it is the probability of A and B that we have. There is A and B. The moment we add its complement of A and B, this one, its complement, it is supposed to give us a 1. So as we have got this one of the or, this one, or A or B, A or B. So it can be calculated. If we want A, we can simply take this one of the complement to the other side. The same thing, if you want A or B, we can simply take this one to the other side. So this is the complement concept. It happens on any combination. On any combination. All right, so that's 7.11, guys, was going to be easily answered that way. So meaning say the probability of A or B is going to be what? 1 minus, we take this to the other side, it becomes a negative probability of A or B complement, which is 1 minus A or B complement. We are given that. What is not A or B? 0.05. We are given that. That's 0.05. So we are going to simply subtract this, get 0.95, just like that. All right. So the probability of A or B is given. We have it, 0.95, just like that. So probability, guys, just try to have your basics, your notes, and this and that. And also you're going to try to work on that one, introductions, going through the textbook so that we understand the basic of what we need. 7.12. Are the two events mutually exclusive? Justify your answer. If two events are mutually exclusive, those are events which are separate. A on its own, B on its own. That is mutually exclusive events. So this is telling us that definitely we do not have probability of A and B is supposed to be equal to 0. Or we can take it from probability of A plus the probability of B. It is supposed to be exactly the probability of A or B. If they are mutually exclusive, they are supposed to be the same, or it can be this one. So you're going to prove it from any part. So the first one, it was something that they need you to calculate on the second part. So you can avoid that one and use, the first one. So you can use the second part to say, if they are mutually exclusive, truly the probability of A or B must be equal to the probability of A plus the probability of B, if truly they're like that. We have, or we are given, we calculated this probability of A or B. We have it. We calculated this, remember. It is there. 0.95. It is there. Now determine that one of A and B separated. The probability of what is in A, we add it to what is in B. Let's add. What is in A? That's 0.25 plus what is in B? That's 0.89. We add these two. You are going to obtain 1.149. These two are not the same, as we can see. The probability of A or B is not equal to the probability of A plus the probability of B. It is not the same. So if it is not the same, therefore these ones, they are not mutually exclusive. They are not. A and B are not mutually exclusive. A and B are not mutually exclusive events, this one. You must be very careful on that one. They are not mutually exclusive events, this one. They are not. Just like that. So it is something that you can prove in different ways. You could have used of the intersection, but you can also prove that both, that is the one they're asking you on this other part here. The probability of A and B, if we calculate this and we do not get a 0, it means they are not mutually exclusive, because mutually exclusive probability of A and B must be what? Must be 0. So let's calculate A and B and see. Remember the probability of A and B, guys. If you are given probability of A or B, there's that formula that I said it works for any event that is happening. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. It works on each combination, whether they are mutually exclusive, they are not any this long. So as we need the probability of A and B. So let's find this. Let's take it this side. It becomes a positive. So probability of A and B, it is equal to what? On the right-hand side, we are remaining with A and B. So it's going to be probability of A plus the probability of B. We take probability of A or B to the other side. So we are going to subtract the probability of A or B, just like that. So this is a formula to be used on any combination, any set. They are mutually exclusive. They are not. This one is not limited anyway. So we have A 0.25 plus that one of B 0.89 minus that of A or B, which we calculated. A or B, remember we calculated and we got 0.95. So the difference there is the one that represents A and B, which was 0.19. So as we can see, it is not equal to 0, because we could have used this one to prove that these ones are mutually exclusive, or they are not. So as we can see, the answer is not 0, so it means they are not mutually exclusive. But as we are answering 7.13, guys, another question that we're answering. So that's it. A and B was to be taken from that one. Then on number 7.14, what is the probability of event B only? What is in B only? How do you find the probability of what is in B? Remember, these sets are not mutually exclusive. So they are inclusive events like this, where there is an intersection. Remember, this is A and B. This is A, this is B. So this is your A and B, this one. A and what? And B. When they talk about B only, this one, what is remaining outside this one? What is remaining here? From B, we have to remove this one A and B to remain with what? B only, this part of B only. So probability of B only, the 7.14, the probability of B only, we must remove A and B because A and B is found in A, it is also found in B. So we have to remove it from B. So it is going to be the probability of B minus the probability of A and B, just like that. We remove the intersection. So the probability of B is there, 0.89. We take that one as it is, 0.89 minus the probability of A and B. We calculated that one. That's 0.19. So the difference that we are having there, which is 0.7, is the probability of what? Of B only. Just like that. All right, 7.2, they said in a small town, 1,500 people. Okay, this is a small town of 1,500 people. There are two main banks, Ed Savings and Multiplier Bank. Most of the people in the town bank with one or both, they have one or both of these banks. 600 of this, all right? This is what we are given. Then they said, draw a Venn diagram to illustrate the information above. All right? Draw a Venn diagram to illustrate this information above. If we are to consider, there are two types of banks that we are given there. All right. There is there's a condition that both can use this. I mean, one person can use both banks. They are saying that most people in the town bank with, okay? Most people in the town, they bank with what? One or both. So you can bank with one or you can bank with both. So there is an intersection there, but we do not know that. So let that intersection be X, the intersection of those ones which are using add savings. Remember, there is add savings and the multiplier bank. Multiplier bank. So there are those who are using both, we call them X. But if we take a closer look, this part of our sample space we are given, there are 1,500 people, which is fine. But they are saying 600 people bank with add savings. Add savings, the whole of this, it has got 600 people. What about those ones who use add savings only? We have to subtract these ones for both. So it was supposed to be 600 minus X because this one, they take both. 950 bank with what? Multiplier bank. This multiplier bank, there are 950 people. Of those 950, there are some who are using both. So we have to remove those ones who are using both. So it was supposed to be 950 minus X. And 235 people in the town do not use either add savings or more. They do not use these two banks. 235. These are the ones that you write outside of these two banks. So as you can see, we have a Venn diagram, but it's not complete. And they are not even asking you about finding this number on another question later on. They're asking about the probability of finding those ones who uses both the banks. 1 mark, meaning to say they want you to calculate everything. They want you to solve everything there. So how are you going to solve everything? Remember, we are told that in this town, there are 1,500 people. So form an equation, adding everything. The 600 minus X, we add to this X, we add to the 950 minus X, we add to the 235. It must be equal to the number of people in the town, which is 1,500. So we can solve for X. Add these numbers together, 600, 950, 235. If you add, it was going to give us 1,785. Then minus X and X cancels. You remain with minus X there. So that's minus X is equal to 1,500. So let's solve for X. Minus X is equal to what? Take this to the other side. It becomes a minus here, 1,785. You subtract that. It was going to give you a negative. That's by subtracting minus 285. So simply divide by minus x. Divide by by minus 1. By minus 1, x was going to be a positive 285. So those ones who are using both banks, they are 285. So we can solve this part. And after solving, we can substitute, all right, as we have our number, which is 285. We can substitute in place of x. Remember, x is those ones that are representing both here. They are 285. So we calculated this. We got 285. There is 950 minus 285. 950 minus 285. We subtract each and every part that we are given. So 950 minus 285 was going to give us 665. We substitute this one. So it was going to be 665. The same 600 minus 850. We subtract 285, sorry, minus this 285. We subtract that. It was going to give us 315. So this is the set that we were supposed to actually represent as with those numbers. So you're supposed to calculate your x, then substitute that in place of the information that you are given. Then later on, they want you to calculate on 7.22 the probability. What is the probability that a person from the town uses both banks? This is both. There are, how many people are there that are using both? 285. So the probability there of using both banks is you are using Ed Savings, and you are also using the multiplier bank. That is the idea there. So how many people are there? This is the 285. So that's 285 out of the total 1,500 people in that town. So that was going to give us 19 over 100, or you can have it as a decimal, 0.19. It's up to you. Or you can even have it as a percentage, just like that. Then on 7.23, what is the probability that a person from the town does not use multiplier bank? The person does not use multiplier bank. Close the multiplier bank if you do not understand and if you are given a diagram like this. Do not, they're saying they do not use this. This is your multiplier bank. Close it like this. This is your multiplier bank. You are not to say you use both. No, you are not having anything to do with multiplier bank. These are the ones who are using Ed Savings only, and those ones who do not use any of these cards. That is the idea there. That is the idea there. They do not use the Ed Saving. They do not use the multiplier. So these are the ones. We add these two. How many do we have? So that was 7.23. It was going to be 315 plus 235 out of the total of 1,500. So that was going to give us 550. It was going to be 550 over 1,500, which is 11 over 30. Or you can use it this way. We need the probability that they do not use the multiplier bank. What is the number of those ones who are using the multiplier bank here? We are told that 950 bank with what? Multiplier bank. So from that 950, another way was simply going to subtract 1,500 minus 950 who are using what? The multiplier bank. By subtracting these 950 from this one, we are going to obtain 550. They do not use the multiplier bank, these ones. Because we have removed 950, though everyone who is using what? Multiplier bank, they're 950. So remove them from the total. So you have 550 and 550 over what? The total. That is now your probability of those ones who do not use what? The multiplier bank as a percentage, as a decimal, whatever that you want. Or you can just leave it as a common fraction, 11 over 30. So these are your typical questions, guys. You just have to be very, very careful on how to attempt these typical questions. So let's revise as much questions as we can. Make sure that you do revise as many questions as we can, and let there be light in our revisions as we are revising for our exams which are ahead of time. Make sure that you give yourself some time, work with question papers, work with introductions of the topics, understand how the questions are given, so that at least it can be of advantage in your revisions. That's it, guys. Till we meet again.